In this video, I will explain frequency differentiation property of the Fourier transform. Frequency differentiation frequency differentiation property of the Fourier transform. The frequency differentiation property of the Fourier transform is Fourier transform of x of t is equal to x of omega. Fourier transform of t into x of t is equal to j into d of x of omega by d. Prove that. Another way of representation is minus j t x of t Fourier transform. This representation is Fourier transform is d of omega by d. Or frequency differentiation property. We know that x of omega is equal to minus infinity to plus infinity. This is the proof. X of t e power minus j omega t dt. Differentiate above equation. Differentiate above equation. With respect to omega. D x of omega by d omega is equal to minus infinity to plus infinity x of t d by d omega of e power minus j omega t. That is equal to minus infinity to plus infinity x of t with respect to omega. D by d omega of e power minus j omega t is e power minus j omega t, and d by d omega of minus j omega t dt. That is equal to minus infinity to plus infinity x of t e power minus j omega t d by d omega of minus j omega t is minus j dt. That is equal to minus j is bring outside. Integral minus infinity to plus infinity x of t into x of t is grouped into one term, that is some g of t or e power minus j omega t dt. That it be the t into x of t is whole term is g of t. Integral minus infinity to plus infinity g of t e power minus j omega t dt is some Fourier transform of g of t minus j Fourier transform of g of t. Fourier transform of g of t is minus infinity to plus infinity g of t e power minus j omega t dt. We know that g of t is equal to generally g of t is equal to t into x of t. Put t into x of t in place of g of t minus j Fourier transform of t into x of t. Here d x of omega by d omega. This can be written as minus j t x of t Fourier transform is d x of omega by d omega. This is a proof. Or here one more d x of omega by d omega minus j term is there. Numerator and denominator is multiplied with the j and Fourier transform of t into x. Take this one. Take this one. D x of omega by d omega j into j square, j into j square, j square is minus 1, minus into minus plus. Fourier transform of t into. Therefore, Fourier transform of t into x of t is equal to j into d x of omega by d omega. This is the important property of the Fourier transform. Or sometimes Fourier transform of t whole power n into x of t is equal to j power n d power n x of omega by d omega whole power. That is proof of this one is this is the another formula. Again, consider x of omega minus infinity to plus infinity x of t e power minus j omega t dt. Differentiate above equation with respect to t, with respect to omega, dx of omega by d omega minus infinity to plus infinity x of t d by d omega of e power minus j omega t dt minus infinity to plus infinity x of t e power minus j omega t. Minus j omega t differentiation with respect to omega is minus jt dt. Again, differentiate. Again, differentiate above equation with respect to omega. Again, another differentiation, that is d by d omega of dx of omega by d omega minus infinity to plus infinity x of t d by d omega of e power minus j omega t, here minus jt dt. Here d square x of omega d omega square is equal to minus j term is bring outside minus infinity to plus infinity t into x of t. Again, d by d omega v power minus j omega t is e power minus j omega t. Minus j omega t differentiation with respect to omega is minus jt dt. D square x of omega d omega square is equal to minus j minus infinity to plus infinity. Here t into t square x of t, here one more minus j term is there, minus j term is bring outside, t square x of t e power minus j omega t dt. Here minus into minus plus j into j square, j into j square minus infinity to plus infinity, let it be g of t e power minus j omega t dt. That is equal to j square Fourier transform of g of t. Fourier transform of g of t. Fourier transform of g of t. Fourier transform of g of t is t square x of t. Here a numerator and the denominator is multiplied with j square. Therefore, finally, d square x of omega by d omega square. J square is -1. Here j square is -1 by j square Fourier transform of t square x of t. Finally, Fourier transform of t square x of t is equal to minus into minus plus j square d square x of omega by d omega. Here n is equal to t into x of t means n is equal to 1. Finally, for second differentiation, t square x of t, j square d square x of omega. For third differentiation, Fourier transform of t cube x of t is equal to j cube d cube x of omega by d omega, like that, and so on and so forth. Finally, Fourier transform of t power n x of t is equal to j power n d power n x of omega d power n x of omega by d omega. This is the another formula of Fourier